right, y'all. So let's start looking at this. Factoring. This is the stuff we did yesterday, the around the room kind of thing. And we are practicing that again. So here we have one that has an A value. If we have an A value, we always want to check and see if there's a GCF first. Is there any common factor between 4x squared, 12x, and 9? Is there anything I can pull out of all three pieces? No, and no's a valid answer. All right. So then we're going to X and box it. I'm going to build myself an X. We take our A times C at the top, and our B goes at the bottom. So A times C, what's going to go at the top of my X here? 36, 4 times 9. And my B goes at the bottom, which is 12. So I need a pair of numbers that multiplies to be 36 and adds to be 12. When in doubt, if you get stuck at this point, take your multiples, like see, I'm multiplying to be 36, and say, all right, what multiplies to make 36? 1 and 36, 2 and 18. Eventually, you'll spot it as 6 and 6. Oops. Come on. Pen, can we work right? 6 and 6. But it's absolutely valid to make yourself a little factor tree. Or a list of factors. Because then we can put this through our box. Where we have 4x squared from our expression. 9 from our expression, and then our middle term splits to be 6x and 6x. So what are our factors going to be? 2x and 3 and 2x and 3. So we have a factored form of 2x plus 3 times 2x plus 3. Or we could write this as 2x plus 3 squared. Questions on that first one? How about the second one? The second one has a shortcut option, which we love a shortcut. First things first, it does have an A value, so we are once again going to check and see if there's a greatest common factor. Is there a greatest common factor here? But what do we notice about this? It's a negative 25. 9 and 25 are both what? Perfect squares. So I have the difference, which means subtraction, of perfect squares. Difference of squares. So what we can do is we can follow the special pattern. Where I'm going to be like, all right, we can get this sucker in factored form real fast. What is the square root of 9x squared? 3x. So I can take and put 3x in the front piece of both of these. What is the square root of 25? 5. We put that one in the back. And then we have one has a plus, one has minus. And we're done. If we notice that it's a difference of squares, we can take a shortcut. If you don't notice that, it's 100% still valid to X and box it. It'll be the exact same process we had up above. 100%. Totally fine. We're just going to wind up with a very large number in our X frame because it's going to be 9 times 25, which is going to be 225. Ugh. But doable. We just wind up with a positive 15, negative 15 on either side of our X box, or our X frame. Okay, so noticing this pattern will be simpler. Okay? So we are going to get firmly into our new chapter today. Yesterday was 100% review of factoring. Today we're going to figure out why the heck I cared so much about you remembering factoring. Ugh, gross. We hate factoring. But our next chapter is something called rational functions. And I know they don't necessarily always feel rational, but they're called a rational function. And all that is it's going to be something that winds up looking like this guy way down here, where we have usually x's, almost always as binomials in a fraction. So it's going to have pieces that look like factors in fractions. And for it to be a rational function, there's going to be an x in the denominator. We've tried really, really hard when we're solving not to divide by x's and stuff, because we had to wait until now to deal with x's in the denominator. And so what we're going to do is today we're going to work on simplifying these really kind of gross looking fractions. And we're going to use the same concept we use when we simplify other fractions, not that are just typed into the calculator. Because what we're doing is we are factoring here. We're finding factors. This was, in this case, finding factors of 35 is 5 times 7. Finding factors of 45 is 5 times 8. And we can cancel out pieces. As long as it's exactly the same on the top and the bottom, and they're being multiplied together, we can cancel them out. So things that are multiplied together and are exactly the same. Okay? So they give us an example down here where they've taken this two quadratics and made a fraction of them. And they're like, we want to simplify this. So what they did to get from here over here was they factored, just like we did in the bell work. And then once again down here, they factored. Told you it was going to be a really important piece in this chapter. It's literally the first step is to factor the top, factor the bottom. In this one, when we look at it, we had x plus 5 times x plus 2 over x minus 3 times x plus 2. Since my x plus 2's are identical, x plus 2 over x plus 2, that is the same thing as 1. It cancels out. As long as it's exactly the same, top and bottom, they cancel out. And this is what we're going to have be our simplified form for today. This is where we're going to stop. So what we're going to do is we're going to hop right in. So this is example 1 in your book, but I would rather you do it on the paper so you actually have to write stuff. Because when we look at these things, we look at that and we go, ew, there's so much there, and it's a whole lot of gross. Take it piece by piece. I'm going to take my top piece, and we are going to factor it. So I'm going to give us an x and a box. And we're going to factor this guy. And you may or may not need a box. When we factor it, I'm going to put it over on this side so that we're clear what's going on. So we're just looking at the top piece, and we're going to fill in for factoring. We got our a times c. What goes to the top of my frame? Negative 24. What goes at the bottom? Negative 2. We need a pair of numbers that multiplies to be negative 24 and adds to be negative 2. 4 and 6, and the 6 is going to be negative. 4 and negative 6. Our a value is 1, so we don't necessarily need the box, but it's 100% valid to do so. So we're going to take our x squared and our minus 24 from our equation. And we're going to take our minus 6x and our 4x to pull our factors. We're going to have our, what's shared here is our x. Negative 6x and negative 24 share a negative 6. My top row, x squared minus 6x, they share an x. And my bottom row, 4x minus 24 is a positive 4. So I'm going to come over to my right side where I'm putting my simplified version, and we're going to put our x minus 6, x plus 4 on the top. All we did to get from here over to here was we factored. And this side is just my work. Just to be clear. Hello, my dear. Thank you, dear. Got a little handout from by the tray. We're going to do the same thing on the bottom. We're going to look at this bottom one and go, there's lots of things there. I see an x cubed. That's scary and gross.
I'm sorry.
I was not talking to you. She's so nosy. Goodness. So, we're going to look at this. And first things first, I definitely have an A value. So we're going to see, is there a GCF here? Is there a greatest common factor? Is there something I can take out of all three pieces? 2. Is there anything else I can take out of all three pieces? I can take an x out. So we're going to factor out a 2x. 2x cubed divided by 2x leaves me with x squared. 6x squared divided by 2x gives me 3x, because I'm good at mathing. Woohoo, yay for me. And minus 8x divided by 2x gives me minus 4. Always, always, always check for a GCF, because it'll probably make you, it will make your life easier. It will also make your answers correct. All right, so now what we're going to do is we're going to X and box this guy. So our A times C, the 1 times the negative 4 is negative 4, and my B value is 3. So we need a pair of numbers that multiplies to be negative 4, adds to be positive 3. What pair of numbers adds to be multiplies to be negative 4 and adds to be 3? What pair of numbers would work there? 4, negative 1. So in this guy, we definitely have our A is equal to 1, so we can go ahead and go straight into our factored form, taking a shortcut. So we have our GCF of 2x, and we're going to have our x plus 4 and x minus 1. If you still want to box it, that's totally fine. I'm going to change the view for a second so you guys can actually see. Because now what we're doing is we're just going to look at this piece. Our factored version. Do we have any pieces that are exactly the same top and bottom? X plus 4. I've got an x plus 4 here, and I have an x plus 4 here. If I have the exact same thing top and bottom, what can I do with it? Cancel it out. So our answer here, our simplified version, is going to be just to rewrite the pieces that are left over. We have x minus 6 over 2x times x minus 1. And this guy is our answer. Should we zoom it in so we didn't get distracted by all the things. And then there's this random sentence down below. There's a couple of times when this thing doesn't work. What is the one thing in the existence of the universe of math that we cannot divide by? What can my denominator never, ever, ever be? Zero. The expression, that's what the sentence means. The expression is undefined when the denominator is equal to 0. So we want to know, when is this guy going to equal to 0? I'm not going to underline it because it looks like another fraction. When does this equal 0? For what values of x are any of these pieces going to be 0? So we're going to take our little chunks. I want to know, when is this piece going to be 0? And when is this piece going to be 0? So what we do is we say, when does 2x equal 0? When x equals what? 0. And then when does this piece equal 0? When does x minus 1 equal 0? When x is 1. So we have to figure out the places where it doesn't work, and that's any place our denominator is 0. It is undefined when our denominator is 0. But this is the first time we're really seeing one of these rational functions. So we factor top, factor bottom, try and cancel things out. Watch out for when our denominator is 0. We're going to do another one of these. But questions on this first one, because these suckers are a little weird. But now we can start to see why I pushed the factoring so hard yesterday. Because we're going to do another one. This is the page 452 check. It is also on the back of the paper you picked up, because I wanted you all to have space to write. This chapter is going to have a whole lot more physically copied notes. Next chapter is going to be all entirely physically copied notes. Just because the book did they made bold choices, and we're going to go with bold and not good on this chapter and next chapter. So we're going to use our books very, very little over the next couple of chapters. But that's okay. So we're going to look at this piece here, and we're going to do the same exact thing. I'm going to take my top piece, and we're going to factor it. I'm going to come over here. We're going to take our a times c. What's going to go at the top of my x frame here? 1. A is 1, c is 1, 1 times 1 is 1. Woohoo! What goes at the bottom? 2. Now I need a pair of numbers that multiplies to be 1 and adds to be 2. 1 and 1. If our a value is 1, we can go ahead and top right into our factored form, taking our pieces from our frame, where we have our x plus 1 and x plus 1. If you want to box it, more power to you. But when your a value is 1, you're going to wind up using just these pieces. For our denominator here, our a value is not 1. So first things first, we look for a GCF. Does this one have a GCF? Nope. So we're going to do the full-on X and box. If your a value is not 1, you have to use some tool to help you factor it. So we're going to fill in our x frame first. What's going to go on the top here? negative 4. My A is 4, my C is negative 1, so we get negative 4 on the top. What's going on the bottom? 3. I need a pair of numbers that multiplies to make negative 4 and adds to make 3. 4 and negative 1. So we're going to fill in our box. I'm going to do the box if you choose to do factoring by grouping or split the middle, whatever you choose. Do something you know how to do. And then our middle term, that 3x, splits into be 4x and minus 1x. So writing down our factors, I'm going to go sideways to start. What is shared between 4x squared and 4x? 4 and x. Both things are there. What is shared between minus 1x and minus 1? It's like I can't take an x out of this guy. But I can take a negative 1 out of both of them. So be real careful when pulling your factors. What is shared in this first column?
X.
Just an x. What is shared in this second column?
1.
Just 1. So when we put it in our factored form, we get x plus 1 and 4x minus 1. So looking at our two pieces, what do we have that's going to cancel out? An x plus 1. So I have 1x plus 1 on the bottom, which means I can cancel out 1x plus 1 on the top. And our simplified answer is x plus 1 over 4x minus 1. This guy's our answer. We again have to pay attention to our expression is undefined when the denominator is equal to 0. So when does 4x minus 1 equal 0? Not when x is 0. But I see where you're thinking that. It's when 4x minus 1 equals 0. So how can I figure out what x is? What can I do to get x by itself? Add 1. Oop. Ah! My screen's freaking out now. That is not what I intended to do. There we go. There we go. I'm going to go ahead and add 1. We have 4x equals 1. How do I get x by itself? Divide by, not divide by 1,
4.
by 4. And we get x equals 1/4. So our function is undefined when x equals 1/4. So these things are weird. They take some practice. You have to factor all the pieces. Okay, so there's a lot of factoring going on here. So you can do the first, I think you can do the first 3, but it might just be the first 2 on homework 1. So this will be, let me get a color that I can actually write with. So this is homework 9-1. And this is going to be simplifying stuff. The rest of this we're going to talk about tomorrow. All right, so you can get started on that. If you were one of my friends that needed a little bit more time on the around the room, now is an excellent time to do that. You guys have about 10 minutes until announcements start. Otherwise, get started on the homework. It'll save your work. Do the thing, okay? Let me know if you guys have any questions, but that is all for today. What's up?
You know, one question on that test.
Yeah, I gotta get it out the door. Okay, so we're given that equation, right? So we have n to the equals 200 e to the minus 0.4. What do we ask? Okay, cool. So I want to know when we have the 50. So where am I going to put the 50 in here? Is 50 the amount of time? Did we change the formulas when we're given the formula? No. So we got to find a variable in here. Oh, this is f of t. F of t is fancy talk for what variable replaces this whole piece. When I say f of x, what does that mean? It's not slow. Not y(x), just y. You kind of make it harder than you need to. So this is y equals 200 e to the minus 0.4 something. So if I want to know when, what variable are we going to have left over? T. So my answer is going to be t equals something. So where am I going to put that 50? Not in t, because my answer is going to be t. Where do you see it in A, huh? Use the equation that you were given.
So I would put it in T.
My answer is going to be t equals, so I don't want to fill t in. What other variable do I have?
Or
What other variable do I have?
Y.
Y. Put it in the y. Don't try and make a brand new equation when I give you one. Use the one you have. We put our 50 in here because it's our total. How many variables do I have left?
Just have T left.
Just t. Can I solve for that variable now?
Yeah.
Yes. Think so.
Would you just type this to the calculator and then divide it?
No. Because in order to get the t out of the exponent, I have to use logarithm. Okay, so you have to get your exponential by itself, then log both sides. Okay, but that's what we do with that. Don't try and write brand new equations. I like that you remembered the AERT thing, but don't write a new equation if I give you one. Yeah, my Richard classical is big pet.